Hello and welcome everyone. My name is Michael Neuert and this webinar is entitled 5G is Here, How to Protect Your Health. So what is 5G? What can you do about it? Can you measure it? Can you shield it? Can you avoid it? And what about those new frequencies you've been hearing of, especially the ones that are called millimeter waves? We're going to go through all of these things today. In this webinar, we will explore some of the most important things that you need to know about 5G, its various components, frequencies, and what you can do to protect yourself. If you don't know me, my name is Michael Neuert. I have a degree in psychology and a degree in engineering. I've been doing this kind of work for almost 30 years. I'm also a licensed electrical contractor, and I've been working with highly sensitive clients for almost 30 years. And I consider the highly sensitive people often are the ones that teach us more about EMFs than anybody. I should let you know I am not a medical doctor or a licensed healthcare practitioner. I am an engineer. And all the information here is from my own assessment of the scientific literature, as well as a lot of information from my own anecdotal experience with actually thousands of clients over the last almost 30 years. And in this presentation, we won't be able to go into great detail about health effects. But if you want more information about health effects, please go to our website, emfcenter.com. And also at our website, if you want to get up-to-date information on 5G, we have, if you go to our website, emfcenter.com, under the EMF info tab, we have a tab, a page for 5G info. We try to keep the most latest information we have there. So I want to make 4 major points about 5G today. If there's 4 things to take away from the webinar today, these would be the 4 things. First is that 5G in some ways is just more of the same. Mostly similar actually to 4G, but just more, and we'll go over that a little bit. Another thing is it'll be helpful to consider 2 kinds of 5G. We're going to be calling one kind the high band and the other the sub 8 gigahertz. And we'll get into what that is and why that's important. And then your own 5G stuff. This is really your worst 5G exposures. We tend to be worried about satellites or things like that, but the stuff that's near you is usually your strongest exposure. And then what is your best defense with 5G for your health? And that's probably to have the right test meters to detect it. So 5G in many ways is just more of 4G. Except we have more data transfer, more speed, more bandwidth, more frequencies, more antennas, more devices, more technologies. It's really the Internet of Things. So this has to do with so many wireless devices just in this home. Look, here's a wireless device, a wireless device, a wireless device. You know, and then this TV is probably wireless. There's probably a Wi-Fi router over here, and there's probably a wireless thermostat over here. And in other words, there's so many wireless devices, and 5G is introducing more and more. And a lot of that involves the increased data that's needed for downloading videos and streaming videos. But there's also a lot of appliances now that have Wi-Fi, and like here's a washer with that has Wi-Fi in it. And there's so many devices now that you have to be a little careful. A lot of people don't know that they have smart meters on their house. A lot of times people don't know that their TV is Wi-Fi and Bluetooth. A lot of the stereo components and TV components, a lot of these boxes will have wireless in them. Your refrigerator could be wireless. There's so many things. Here we have wireless thermostats are very common now, wireless security systems, even things, of course, like baby monitors. It's getting very hard to find a baby monitor that isn't wireless. And then, of course, the coming of self-driving cars. All part of the Internet of Things, where everything is connected to the Internet, everything from our light bulbs, of all things, to our wristwatches, to our computers. So, a quick little update about the generations. 5G just means fifth generation. It's a broad term, but something to look at. You can see like here's the original brick phone, and here's now the kind of phones we have now that are coming out. Now, when cell phones technology started, look at this 25 kbps. This is kilobits per second. Think of a bit as like a little information packet. And so in those days, we had 25,000 bits per second was the ability. And then with 2G, we increased that for about 4 times, 100 bits, 100,000 bits per second. 3G up that a little bit more, see more information, another factor of 4. And to 400,000 bits per second. But now look at the next jump. 4G is a big jump with more data. 100 megabits per second. That's 100 million bits, no longer in the thousands. So we have a jump of over 100-fold. And then what's trying to happen with 5G right now, more in the Internet of Things, so much more data. So basically this 10 gigabits per second, that's 10 trillion bits per second. So you have 10 trillion pieces of information flowing in 1 second as a possibility compared to the original 25,000 in a second. So you can see this is really amping up. But one thing to think about with 1G to 2G to 3G to 4G, it isn't like we have 3G and then all of a sudden 3G ends and then we start 4G and it's like this big step up. It's actually something more like this. There's a ramping up. In fact, like right now, there's still much more 4G being used in 2021 than there is 5G. You can think of ourselves as somewhere like in this point, if this is like time here. There's a lot of 4G happening. In fact, a lot of 5G infrastructure is still using 4G. But what is happening, of course, these are no longer available, the 1G and 2G, but now the 3G is getting less and less available too. So there's this kind of general ramp up. And basically, the initial 5G really began in 2020, and we're expecting that maybe half of the phones will be 5G in 2025, and then full deployment of the whole 5G system in all the many ways, maybe in 2030. That's a rough guess. So 5G is really a collection of many different things. The old 3G and 4G frequencies are no longer sufficient to handle all the wireless data transfer needs that we have now. So more frequencies, more speed, more bandwidth are being added to the system, and also then more antennas and more devices are being added. So it's just more and a lot more. And we're not talking about like a factor of 2. You saw that amount of data. We're talking like a factor of 100 more. So one part of 5G is more frequencies in the same range as 3G and 4G. Most 5G frequencies that are being added, so that we have more frequencies, are in the same frequency range as the existing 3G and 4G. These are called low band and mid band, and they're all below 8 gigahertz. And we'll look at that a little more in a minute. And these are the best frequencies available to get into buildings, get around obstacles. This is the vast majority of 5G signals being used now and that will be used. Then there's also some higher 5G frequencies that are being added. And this is what you often hear about more. These are called high band frequencies. They're generally above 8 gigahertz, up to 200 gigahertz. They can carry much more data and information and actually then have more energy to disrupt our health. They do not travel as far. They are more easily affected by weather events. They're more easily blocked or shielded by standard building materials. So many more antennas are needed, and antennas closer to the user, inside the home, outside the home. So the system requires lots of new costly infrastructure to implement. This is, again, the higher frequencies, this high band. So right now, there's limited usage, mostly being planned for dense urban areas, things like sports arenas. And at this time, the frequencies are still in the process of being opened up, and there's a lot of uncertainty about the details, which frequencies will be used, and country by country, it's a little bit different too. So everything today we're talking about the USA, but it generally applies to the rest of the world also. So part of this is something called the millimeter waves. You've may have heard of that. The new higher 5G frequencies, these high band frequencies that are coming, have shorter wavelengths. They're smaller sized waves. they're called millimeter waves. So millimeter waves are becoming so small, they're becoming the size of our small body parts. And this is one of the reasons why the health effects are largely unknown for millimeter waves. They have not been that common in our environment yet. This is something that's new that's coming to use these small wavelengths for so much communication. I don't know what's going to happen with this, but we're expecting similar health effects as with the existing 4G wavelengths, or maybe worse. And just a quick little thing so you get a little idea about this thing with the size of the waves. The mid-band 5G, which is what most 5G is and what most 3G and 4G is and was, one of the frequencies in there is 2.4 gigahertz. Now, that's one of the frequencies used by Wi-Fi. It's even the frequency that's used by microwave ovens. But what's interesting is that frequency is about 5 inches in size. That's the size of the wave. And that's important because antennas, when you're broadcasting an EMF or receiving EMF, you get the best resonance or coupling effect, like the energy passing from the antenna to the air to the antenna, when you have similar sized antennas as the field itself. So what's interesting about this 5 inches, that's about the size of the brain. So if you had just took our brain, it's actually already at a very good size for matching the wavelength of this 2.4 gigahertz signal that's common in the mid-band 5G. And so the brain in some ways could be a very good receptor to this particular frequency. So this is some of the worries about the high band frequencies also. So 60 gigahertz, if we had that, if that was available, that'd be about 5 millimeters, 200 gigahertz, 1.5 millimeter. These are all high band frequencies. Now the sweat glands consist of little coiled tubes that are about 2 to 5 millimeters long. It's kind of like this. So there's some speculation because the sweat glands are conductive, they can actually work like good little antennas. So our sweat glands are already good antennas for picking up millimeter waves. So we don't know what's all going to happen with this for our health yet, but that's one of the concerns. And then another part of 5G is just more antennas, smaller antennas, closer antennas to us. Many more small cells. These are cellular base stations. They're needed, more of them closer to us. These small cells are often installed every 400 to 900 feet, for example, along streets on the power poles and the light poles. So there's different sizes of the small cells. The microcells and the picocells, these are relatively small cell antennas. They're mounted on buildings and power poles. Then femtocells, these are even smaller cell towers. Cells, they're not really towers anymore. They're kind of like today's Wi-Fi hotspots, like in a commercial building. There's going to be actually like little cell towers in buildings, not just outside, they're a mile away. Little versions of cellular antennas inside buildings. And even drones and balloons can position small cells. And then, of course, a lot of the concerns about satellites, because they're becoming increasingly important for some of the 5G services, especially in remote and rural areas. Then we also, so just to, here's a little example, 4G and 5G small cells in neighborhoods. It was already coming with 4G, and it's definitely coming with 5G. It's going to depend on the neighborhood, but see like these antennas here on the poles. Here in this neighborhood, every antenna has a little small cell on it. Here's a small cell over here. You're going to see different versions coming. Some neighborhoods will get it, some will not. And the denser the neighborhood, the more likely you're going to have more of these. And then another part of this is just many more 5G devices being used. So many appliances and electronics will have wireless in it, whether you like it or not. And often people, without people even knowing that their devices are wireless. So this can include lighting controls, thermostats, environmental controls, furnaces, irrigation systems, security systems. Almost anything can be wireless, from baby scales and cribs to your washing machine and your clothes dryer. And I'm not kidding. And we did have a client who actually had a Wi-Fi baby crib and a baby scale so that she could be anywhere and checking her cell phone. And if the nurse, if the person caring for her baby, put the baby on the scale, she could see what the baby's weight was. I don't know that we really need those kind of things, but that's the kind of thing that's already here and coming much more. And of course, the worst case for all these devices is anything that's worn on your body. Again, this is all the Internet of Things. Another thing that you might have heard of, just so you have a little understanding, is beamforming, massive MIMO, and some of the other technologies. Basically, this has to do with more focused, directed, and targeted RF signal beams rather than 360 degrees in all directions. And so in these systems, the system steers the RF beam constantly. Like if you're driving along, the beam keeps on getting steered towards your car for optimum line of sight communications. The good thing about it is you have less spillover, but in the direction it is sending, you have a stronger signal. Wireless systems then can reuse that same frequency in multiple directions and other locations nearby. To give you a little idea. So in the middle here, this is how regular cell antennas are. You'll see 3 antennas and they kind of go 120 degrees in one direction, in another direction, and there's one signal with one cell phone in that whole direction. But now the antennas with the beam forming and the multiple in, multiple output, you have one antenna site sends a signal over here to this phone, a signal over here to this phone. You can get a lot more signals out of that same antenna instead of it just having one in the area. And the beams look something like this. You can see it's a stronger beam. It goes further. And it's not perfect in one direction. There's these little lobes. This happens with cell towers too, where there's higher and lower exposures near the antenna. So like a lot of things, if you're close to the antenna, there's all kinds of exposures you get. And then the last thing is 5G signals are probably more toxic. And some of this is my opinion, and we'll see what the research shows over the years. The new 5G technologies generally pack more data and information into the same old RF frequencies more than ever before. Thus, the 5G technologies are generating new types of enhanced radio frequency signals, perhaps with a dirtier quality that may actually be more toxic. Think of, you can have two chemicals. They can have, you can have 5 ounces of this chemical and 5 ounces of that chemical, but one might be more toxic than the other. They both might have some kind of effect on your health, but one can be much more toxic than the other. And that's what's happening. Pretty much we find it anecdotally with every jump from one generation to the next, even at reduced power levels. The next generation appears to be more toxic than the previous one, and sensitive people generally report being more affected. For instance, when 4G came in, they could use their 3G phone, but the 4G phone made them sick. And that's very typical and what we expect to be happening as 5G unfolds much more. So basically, let's look at the two kinds of 5G. Everybody's seen rainbows, and you may or may not be aware that a rainbow is part of the electromagnetic spectrum. The frequencies of light are much higher in frequency than the things like our 5G is. But if you had the eyes to see all the other frequencies, like we can see from violet down to red, but if you had eyes to see it, you'd also see ultraviolet's over here. You'd see infrared, and then you start seeing radio frequencies, and before you know it, you'd see like power line fields. And so this radio frequency type of EMF, this fills a large, see, here's the rainbow, and then here's infrared, and then here's the radio frequency sections in frequencies. So way beyond the red of the rainbow. And if you could see even farther, you'd see the fields from power lines. Now, 3G and 4G use a certain set of frequencies in the radio frequency band. I'm kind of showing it roughly here. So, and one of the reasons these frequencies are used is because they're really the best frequencies to get through walls, get around things, and yet carry a fairly large amount of data information. And 5G low band, it's one of the, some of the new frequencies being opened up for 5G, but it's called low band. That's still in that same frequency range of 3G and 4G, and it's kind of like this lower half of what is already 3G and 4G. And then 5G mid-band, that's this part of this here. Again, in the same old frequency range that we had for 3G and 4G, but we're opening up more frequencies in there. So these mid-band and low-band 5G frequencies are very similar to 3G and 4G in their frequency. And then we have the high band, and this is where it gets a little bit different. So here we have added we're adding more frequencies into the mix. So this is the new part of 5G frequencies. So it's helpful to think of two different kinds of EMFs because it's such a wide range, I should say, or kinds of 5G. So one is, think of everything that's less than 5G, I'm sorry, all the 5G that's less than 8 gigahertz, the low band and the mid band, that's I'm going to call sub 8 gigahertz. That's all of the 5G and the 3G and the 4G that's all below 8 gigahertz. And 8 gigahertz is sort of a rough number. I could have said 10 or 12 gigahertz. We're going to work with 8 gigahertz here as sort of the dividing line. And then think of high band as all the 5G that's above 8 gigahertz. You have these two different types, and it's helpful because the two different types need different test meter requirements, and shielding works different for each. So we're kind of going to make it into those two categories here. And basically right now in the USA, these are the frequencies that are being used for low band, mid band, and high band. And it will differ from country to country. And this is going to even open up more as things like here in the FCC, in the USA, the FCC opens up more frequencies for use. Like this high band area, there's a lot more frequencies that will come in here in the future. So basically we're looking at the sub 8 gigahertz is the low band and the mid band. And then the high band is these frequencies that are above 8 gigahertz. So just keep that in mind as we go through the rest of the webinar. And so which ones will be used the most? That's actually a good question because you think, oh, won't they use this? Well, no, we're going to go into a little bit. Why not? The main frequencies that are going to be used most will be these. And then these will also be used, but to a lesser degree, and probably these will be used the least. The high band will probably be used the least. Some of this we're only going to see in the coming years to know for sure. And why is this important? It's important because for shielding purposes, these high frequencies are relatively easy to shield. They don't travel very far. They don't get through walls very well. These frequencies are very much like the 3G and 4G. So the same materials we use now to shield 3G and 4G signals work for these 5G low band and high band signals. And also it also means the test meters we already have for 3G and 4G, they work well for these sub 8 gigahertz types of signals. So let's get into your own stuff. What causes your exposures to 5G? So I kind of have four categories. One is things close to your body, like within an inch. Things in your house, like maybe 1 to 50 feet around you. Things in your neighborhood, maybe 50 feet to a quarter of a mile around you. And then what's coming from the sky, which is satellites more than hundreds of miles up. So when we're looking at our priorities, what's the most important 5G exposures to reduce? Here's the way I see it. Priority A is 5G on your body. Priority B, 5G in your house. Priority C, 5G in your neighborhood. And then the last priority, 5G in your skyline. Partly because the things that are in the sky are so much farther away. The things in your body are the closest to you. And distance is huge. A device at your head usually gives you much stronger exposure than, say, a smart meter over at your neighbor's house. So let's look at 5G on the body. Of course, cell phones, obvious one. Part of your brain is getting some fairly strong exposure. But now there's so many other things like Fitbit exercise equipment, watches that are wireless and connected to the internet. Cell phones, tablets, Wi-Fi computers, cordless mice and keyboards, hearing aids, there's all kinds of things that people are wearing now or touching that are causing more RF exposures. So remember, wearing 5G and touching 5G devices that causes your strongest exposures. Those are the most important ones to worry about. And then second priority, 5G in your house. Again, so many wireless devices in many houses. And if you're the person here and you were just sitting without a computer and you were like watching TV or something, you're getting the exposure from the person up here on the second floor who's using their cell phone, or you're getting the exposure from the wireless router that's in the next room. So you get significant exposures in your own house depending how close you are. And remember, these radio frequencies that are being used, they're very good at getting through walls, through doorways, down stairways. That's why they're being used for these communication purposes, because they tend to get in and around things so well. And then, of course, in your house, there's the obvious things. There's the wireless system devices, things like your a Wi-Fi router, the gateway you might have for your broadband service, Wi-Fi repeaters showing up in many houses. Where you work, you might have a Wi-Fi hotspot right above you. There's all kinds of devices that are sending the antennas that are being used. So those are obvious sources. And then there's ones which are less obvious. Some people might know, not know that they have a smart meter, or they might not know that their smart meter from a neighbor is kind of entering their house. Again, all this equipment for the entertainment system, all these different devices could have wireless in them. Your refrigerator could have wireless in it. Your thermostat could have wireless. Your security system, baby monitors. There's so many possibilities. And even people sometimes miss solar inverters and systems often have a wireless component. It doesn't have to, but they often do. They're often connecting with the cell tower, so that you could be in South Africa and check your cell phone and find out what amount of solar energy you're living in Pasadena, and you could see what level of energy is being putting out by your solar system. That's often done via wireless connections. So to be aware that you could have wireless even with a solar system. So in most cases, 5G devices in your home often cause your second strongest level of exposures. Again, because you're fairly close to them. And then what about 5G in your neighborhood? So say you were buying a new house or renting an apartment, of course you'd want to avoid these obvious things, the cell towers you can see. But you have to, this is where it helps to have a meter, because there can be hidden sources. These are all 4G cell phone antenna sites, and you would maybe not know that. And what is really happening now is the increase of small cells in neighborhoods. So the concern here is, if you're going to buy a house, you of course want to maybe avoid a house that on your side of the street already has the little 5G cell antennas on it. It'd be better if this was across the street. But basically, people who are concerned about this, they're looking for houses now where there's a greater distance, right, between the house and the street. Because even if there are not small cells on the street outside the house right now, in 2 years that might be there. So to be sort of proactive, people are looking for houses where there's more of a setback from the street, because the most likely place in neighborhoods for these small cells will be on the telephone poles, power poles, light poles. And of course, we want to avoid, there's going to be a lot of, here's a shopping center, and then here's a small cell system right there. And another thing to be really aware of is your neighbors' devices. So in your neighborhood, often your strongest exposures are from your neighbors. So for instance, here, say this was your room here, say that was your bedroom, and then right over here, maybe there's a smart meter, or right over here, the neighbor has an office and they have a Wi-Fi router in there. So the signal from the Wi-Fi router goes through the air here, through your window, and sometimes you can get stronger exposures from a neighbor's Wi-Fi than you would from a Wi-Fi in the same house downstairs and on the other side of the house, because it goes right through the windows. So another thing that people are doing when they're looking for houses, places to live, is they're trying to find houses that have a greater distance from neighbors, because the closer you are, the more susceptible you are to your neighbor's devices. And then, of course, what's going to be coming, there's already radar protection on cars. So as you go down roads, there's a certain amount of radar that you're getting from cars. But with the advent of self-driving vehicles at some point, the streets in your neighborhood could become very significant sources of 5G signals also. Of course, at this point, self-driving cars are not there. We don't have the infrastructure, but that's one of the things that 5G is trying to do, what the telecom companies are trying to do, is get ready for that eventuality of having things like self-driving vehicles. So neighborhood 5G devices can also cause significant RF exposures, but typically not as strong as the stuff that's on your body or the things that are nearby in the same room or the same house. And then what about 5G in your skyline? So the thing that we're aware of is wireless 5G internet via satellites in orbit. And you're hearing more about that. And that's because right now, thousands of satellites are being launched. Excuse me. Rumors of maybe up to 50,000 someday. Hundreds of miles away in orbit above the Earth. Remember this number here, 50,000, because we're going to compare that to something else in a minute. Because these satellites are so far away, our exposure is relatively low to us here at the ground level. The satellites are being used mostly for rural areas, remote areas, and to fill in certain gaps in urban areas. The space satellites are not preferred by the telecom companies due to their higher cost and their latency issues. It has to do with when you send a signal to a satellite and say the satellite is 450 miles up, it has to travel 450 miles and come back 450 miles. That there's a little bit of lag in the signal, and thus the computers look like they're running a little slow. So the telecoms like to have communication systems that are closer, not hundreds of miles away. So the telecoms prefer ground-to-ground terrestrial internet type of situations. Typically, these are within 10 or 20 miles. So what that is like here on the left is an example. This is a 900 megahertz system. There can be many different frequencies, but here we have a point-to-point ground-based fixed wireless internet where you have a dish on your property and there's a dish somewhere, perhaps on a tower, and they're communicating back and forth, often for like this one is set up for up to 18 miles. On the right here, we have an example of another site-to-site sort of antenna. Don't know what it's looking at or what it's receiving from, but this is for a commercial building, and there's signals going out and back via that. So remember that number 50,000 someday of satellites around the Earth? It sounds like a lot, right? But think of these satellites as like another cell tower, but a cell tower in the sky. What about the cell towers on the ground right now? This is actually information from 2019, so it's already a little old. In just the US by itself, we're not talking about the world, just the US, 350,000 cell towers. Now, and that's actually cell towers. If you look at cell sites, these are not just towers, but things on buildings, flagpoles. In just the US, over 1 million cell sites. So you can see even in the future, we're expecting to have 50,000 cell towers in the sky, but we already have well over 1 million cell sites here on the ground and that's just the US. And to me, this is the biggest concern, more than the satellites, because these are relatively stronger EMF exposures compared to these on the ground exposures are stronger to us typically than the ones that are coming from the sky, because this ground terrestrial is often in the range of 10 to 20 miles away, not 200 miles or 400 miles or 800 miles. So these ground-based systems are used whenever possible by the telecom industry. The satellites are mostly there for rural areas and to fill in certain gaps in urban areas. So these ground-based systems are preferred by the telecoms due to their lower cost and their improved latency issues. Again, this is where if you're going 20 miles to another antenna and back, there's a lot less lag in the signal than if you're going 400 miles. And basically how that looks, you can have tower to tower, but then you have a tower, you basically on your property typically have some kind of dish where you're picking up from a tower like that or whatever, and then you're also sending back to that. It's a little more directed. It's not so much spillover, a little bit of spillover, so you're always concerned about on your property. But basically, this is something that I'm also concerned about, is more and more of these terrestrial site-to-site internet systems. So satellite exposures are generally relatively weak here at the ground, but terrestrial internet can be significant. And I just wanted to mention that we still do have a promotion. This is for anybody who's watching this particular 5G webinar. We do have $50 off the e-course, my e-course. It's been going for a couple of years. We just updated it. It's got a lot of 5G updates, so it's right up to date again. You can use the coupon code and purchase 5G50 if you're interested.